Okay, we have the WaveShare's USB-C output connected to a breakout board so we can measure the voltage, and we're going to use the electric load simulator to simulate the max load, which is set at 250 milliamps. I'm going to turn the load on and see what the output voltage of the USB-C is. And as we can see, we're at 4.94 volts at 250 milliamp load, and that is within our tolerance range. Do it one more time. And we're still at 4.94 volts. Alright, we have the WaveShare module here, and now we are using the 5 volt output, which can be used to connect to the ESP32. We're going to use the electric load simulator to simulate the max load, which is 250 milliamps, and we're going to turn the load on. We can see we're outputting 4.98 volts at our max load. Turn the load on and off again, and we're still getting 4.98 volts. Alright, we're using the WaveShare module's 3.3 volt output to simulate the load of the ESP8266 module, which has a max current rating of, or max load rating of 215 milliamps. And we're going to simulate the load here. See, we're getting exactly 3.3 volts at 215 milliamps. Try it one more time. And again, at our max load, we are getting 3.3 volts, which is within our tolerance range. Here we have the Raspberry Pi 5 volt 3 amp power supply that will be used to power our Raspberry Pi 4. It is connected to a USB-C breakout board, which is then connected to our electric load simulator. We have it rated at 3 amps currently, and when we turn on the load, we do see a significant drop in voltage from our rated 5 volts. We can also test 1 amp, and we see a much better voltage, which is within our tolerance, and when we test half an amp, we get right at 5 volts there. Here we have our LRS50-5 power supply. As we can see, it's connected via power cord to our AC input and gives us a 5 volt DC output. The maximum load that we will be seeing from the motors is 3.6 amps. And so we will turn the load on for the electric load simulator. And we can see 4.94 volts, which is within our tolerance. And then we moved up to 4.98 volts there. So our output voltage is within the tolerance range. Okay, we are testing the solar panel to make sure it is producing current and voltage. We have the solar panel here on a nice and sunny day. Let's see, the meter might be hard to see here, but we're going to set it to make sure it's producing the voltage. You can see it's flickering because it's outside, but we're getting about 22 volts. Move the probe to current, change the meter, and we're getting about 0.3 amps as well. So we are producing a current and a voltage, so the solar panel is working. We've got the WaveShare module connected to the solar input here. We can see that the LED is lit for the solar charge indicator. Going to now test it with the multimeter. Got the probes connected, and you can see the LED is no longer charged, but now we can see that we're getting an output on the meter. Okay, we have the WaveShare module solar panel hooked up here. Pretty sunny day again. Now it is actually connected to the WaveShare module. We can see that the solar charge LED is lit, indicating that the battery is charging. So just go ahead and turn it on to be sure. But it's a little hard to see, but the battery level does indicate that it's charging as well. Plug it into the wallet here. Now we've got our meter set up in current, but we have to connect the probes. now, as we can see, we are actually measuring a current with the wave share module. See, again, it is plugged up. It's a bit hard to see with how close these wires are here. But we are producing a current, and the solar panel is charging the battery for the wave share module.